Welcome to our fourth session of our six-part webinar series brought to you by Rockflow Dynamics. My name is Jessica Kalin from the Rockflow Dynamics Calgary office, and today's session will be hosted by my colleague, Nestor Hernandez. Our topic today is modeling of multiple horizontal wells with hydraulic fractures in 3 simple steps. We would like to thank each and every one of you for joining us today. These are new worlds for us working from home, and we are so honored that you're able to give us 30 minutes of your time for this webinar. Our RFD team is working around the clock to maintain and increase support for our clients, and despite the global changes, we continue to be there for you 24/7. During today's webinar session, all of our attendees' microphones have automatically been muted. Should you have any questions, please navigate to the GoToWebinar pane on the right-hand side of your screen, where you'll find the questions pane. At the end of the session, we'll be addressing as many of these questions as we can, the remainder of which will be answered and posted online for your reference in the coming days. Additionally, this webinar session is being recorded and will be uploaded to our RFD Europe YouTube page, as well as uploaded to your FTP folder on our support website. Should you be left with any further questions following this webinar, please do not hesitate to reach out to our experts by email at asktnav@rfdyn.com. Each webinar in this global tNavigator series is hosted by 6 of our offices worldwide. The first 2 sessions were hosted last week in Aberdeen and Kuala Lumpur. The third and fourth that are occurring this week are being hosted in Houston and Calgary respectively, followed by our sessions next week that will be in Moscow and Perth. Today, we're live from Calgary, Alberta, and we will be discussing modeling of multiple horizontal wells with hydraulic fractures. For upcoming webinar topics, please refer to this list that can be found on the webinar registration page, as well as through our LinkedIn channels. Each of our webinars touch upon a different aspect within the integrated reservoir modeling process that is available in tNavigator. If you are interested in learning more about the complete workflow or would like to start a free trial, please contact us at asktnav@rfdyn.com. Now I would like to introduce you to Nestor Hernandez.
Thank you, Jessica. Let me show my screen here. 1 second. So today we're gonna talk about how to model multiple horizontal wells with hydraulic fractures in 3 simple steps. Our agenda today, we will go through the methods to model hydraulic fractures in tNavigator. Then we will do a little demo with how to add fracs to a model with 3 simple steps, and at the end we will have a question and answer section. In this demonstration, we will be using Model Designer and simulation modules within tNavigator. Now let's go into describing these methods to model hydraulic fractures in tNavigator. We basically have 2 methods to do this. The first one is called virtual connections, and the second is called local grid refinement, or LGR. Now within local grid refinement, we have 4 different ways to do it. The first one is using custom geometry. We can also use fracture tables to facilitate this process. But also we have this method to import geometry and conductivity, which is very popular among our customers right now. And lastly, we have the dynamic stimulated rock volume, DSRV. So let's talk about the virtual connection methods. Basically here in a existing model, we are creating fracture planes. And in those fracture planes, we are adding something that we call virtual connections. Now we can manipulate the efficiency of those connections, and those efficiencies can be dependent on time, pressure, and flow. This method is described in one of our tutorials, tutorial C 5.1, and it is also described in the user manual, of course, and in 2 SPE papers. Now talking about LGR, which is the most popular way to model fracs right now. We have custom geometry method, which is unique in tNavigator because We have the advantage that in Designer, the wells, the grid, and the fractures are independent objects. So we can create any geometries that you can imagine in your fracs. And we have unstructured LGRs in order to handle those complex geometries. But we also have the classic logarithmic and uniform LGRs available. This method is described as well in one of our tutorials, which you can ask your support person locally for more information about this. Now, fracture tables basically a table where we enter the well, the date of the stages depth, and some geometrical parameters, and it creates automatically for us the planar fracture geometries. It's very, very fast and convenient to create that type of geometries. As well, the fractures can intersect the grid in any angle, and we have a tutorial with files and slides that shows how to do this. One method that's very popular right now is to bring geometry and conductivity data from third-party software like Gopher, FracPro, FracGeo. In tNavigator, we support .gslib and .csv formats, and once this information is in Designer, you can manipulate this information in any way you want to create the properties that you need. You can see in the picture that we fully honor for example, the Gopher geometry in this case. And lastly, the dynamic stimulated rock volume, DSRV, which is a method that uses rock compaction tables in order to control the geometry and the properties of the fractures. This method is described in 4 SP papers that you have there in the slide.
Thank you, Nestor, for giving us an overview of the various methods to create hydraulic fracs in tNavigator. Now we want to stop and do a quick poll of the audience to see which method you would be most likely to do. On your screen, you should see a pop-up that just came up with the poll asking you which method would be most likely used within your team, as well as 5 options below: virtual connections, LGR by custom geometry, LGR with fracture tables, LGR with imported geometry and conductivity, or LGR dynamic stimulated rock volume. Please choose which best applies to you, and we'll leave this up for about another 30 seconds or so. Five more seconds. I can see a couple more coming in there. If you guys can choose which would be most likely used by your team. All right, the results are in. Wonderful. Thank you to everyone who took a moment to respond to our poll. It looks like the majority of you prefer LGR by imported geometry and conductivity from sources such as Gopher. If you'd like more information on your preferred frac method, please reach out to your local support team or even reach out to myself at jessica.kalin@rfdyn.com.
Very well, thank you, Jessica. Very interesting result from that poll for sure. Now let's go through the short demo. I'm going to show how to add fracs to an existing model in 3 easy steps. Now let's be clear. Modeling unconventionals is typically not easy. We have to include local grid refinement in most of the cases, which increases complexity to the grid. And because of a bigger grid, we also need to use parallel processing and CPU plus GPU acceleration. Also, PVT modeling tends to be a little bit more complex with oil gas, liquid-rich wet gas, and gas condensate systems. And for sure, we have to account for advanced physics like compaction, Walpole-Perm, diffusion, absorption, non-Darcy flow, frac conductivity degradation versus time, enhanced near frac zone, frac fluid initialization, and many more. However, tNavigator is here to help you save time and money during this process. For this part, I have a video ready here, so I'm gonna just play it. So basically, we start with importing a model, an existing model into Model Designer. So we go to our Model Designer module, create a new project, and we give it a name here. Just click OK on the window there. And first thing, we're gonna move a little bit is window sizes to make room for our objects. Then we go to a project menu and import data from existing model. So we have a model that already has 3 horizontal wells and some properties. So we are gonna load this model. These are the 3 horizontals in 2D and 3D. Let me show you, for example, the porosity for this model. And I'm gonna adjust the grid size here a little. And with the tooltip, I can see the porosity about 11% and permeability is about 1 millidars in this case. I'm gonna show the palette here so you can see the values. Now in version 20.1, we have a very nice new filter that allows to filter the objects in Designer. That makes the life much easier when building big models. One thing I want to make sure is that we have all the 3D properties in all time steps so we can see permeability changing with time, for example. Now for the step 2, we are going to add some fractures here to this model. Initially, we are going to create a fracture arithmetic, which is a tool that allows us to enter properties for the fracture zone, near fracture zone, for example, permeability, saturation regions, rock regions, and so on. I already have some arithmetics here ready in Excel, so I can just copy paste the table here. And basically what I have is permeability in the fracture zone, permeability in the near fracture zone, and saturation number for the fracture zone. So I'm going to close this, and now I'm going to create the fracture table for this project. So just create the new object, and the table is visualized here in this table tab. And there are many columns here that you can customize depending on what you want to model. In this case, I already have a template, which some columns that I found useful for this demo. So I'm just gonna load my template here. And then in Excel, I have this table already preset up with all the information I need. I just need to copy paste from Excel to this table here. So what we have here is basically a column with the wells, with the stage dates, stage depths, and some geometrical quantities. Now for well 3, notice here that we have 2 different half lengths. What's happening is that there's a refract job in the middle of the simulation there. We'll visualize that during the run. So next step, I'm gonna visualize here the fractures table in 3D. And this is fully interactive. You can even change the values of the table and they will change in the 3D window there. One more thing I need to do is to enable this fracture in my schedule. So I create a new rule. It's pretty simple, just add a new rule, and the rule is called enable fracture table, and that's all you need to do. And I also need to make sure that the stage dates are in my time steps. I can link my fracture table here to my time steps. And I want to control these wells. I'm going to introduce a well control using the rule well production limits, and I'm going to control the wells by bottom hole pressure. Well, this model is pretty much ready. I'm gonna save it, and now let's move to step 3. So let's run and analyze this model. First, we hit on the green button there to initialize the model. For this part, I really don't need to see this table anymore, so I can move this window out, so I can see my 3D probably a little bit bigger size here for the 3D. And what I want to see, I'm very interested to see the calculated permeability. Now permeability is a dynamic variable, it's not static. So in order to see the fractures, I want to create a filter. My filter is gonna be permeability higher than the reservoir permeability, so higher than 1 millidarcy. So at the moment there's nothing being visualized because the fractures are still not active. I haven't reached the stage date basically. But since I'm gonna run this model, at some point here I'm gonna see the fracs to appear. Now we see them, and the red color in the grid represents the fracture zone, and the green yellow colors represent the near fracture zone. You can see the values there in the tooltip, and also you can see the orientation are not the same for all the fractures. That's a big advantage on this type of model. Now, right now, you're going to see the refract job there in the third well with those much bigger fracs. And also it's possible to visualize how these bigger fracs interact with the existing fracs. So tNav does a very nice job handling the frac hits here, as you can see in 3D. It doesn't have any problems creating LGRs in those complex geometries. We're gonna see this same grid here in 2D. So let me remove the axis here quickly, and I want to show permeability again. So let me go to layer number 3, and there you can see clearly how those frac hits are handled. Let me activate here the grid size, and this is what we call unstructured LGRs. They are very advanced, and it allows for any geometry to be modeled in any grid basically. And the fracs can have any orientation in your grid. It doesn't have to be parallel to the grid anyway. We can animate this with time and see how the frac hits changes the property with time. We can also visualize, for example, streamlines, and also run this versus time. At the beginning, you will see that fluid is being produced from all stages, but as depletion goes on and the center of the model gets a lower pressure, most production is coming from the edges of the model. Streamlines are very useful to QC your model and to understand how things are moving within the stages. We can also visualize any other calculated properties like pressure. We can activate grid lines in 3D as well. We could also visualize oil saturation, water saturation, gas saturation. Even all these other calculated properties can be visualized. In 2D, we can do the same. We just we need to uncheck the streamlines here. And here we can see gas, water and oil saturation, and pressure. Now let's see the production plots. Here are the production plots for all the wells together. And if we see well number 1 separately, you can see its decline, well number 2. And in well number 3 is where we had this refract job. We can see the increased production by the middle of the history there. So that's about this video. I hope you like it. Now, as a summary for this presentation, we have multiple tools to model fracs in tNavigator that go from virtual connections to LGR methods. It's very easy to add the fracs to the model, either if the model is existing one or if it is a new model. And please go and try yourself. Just contact your local RFD office for the tutorials and get started today.
Thank you everyone for your time and attention today. For your reference, this webinar was recorded and you will be able to view it in the coming days on our RFD Europe YouTube channel, as well as on our support website within your FTP folders. We will now take the final few minutes to answer any questions from the audience. Any remaining questions we don't have time for, we will answer after the session and post online for your reference. I'm going to hand it over to Eddie Evans, one of our reservoir engineers in the Houston office, who will get started with the first couple of questions that have come in. Eddie?
Hi, thanks, thanks, Jessica. I'll let me go through the questions that we got, and I'll get started. Just give me a second. So this one seems to pop up a lot. Would it be possible to use geomechanics to predict hydraulic fracture behavior in tNavigator? And the answer is yes. Currently, this works with the virtual connections. When virtual connections are used and you combine it with the geomechanics module, the fracture propagation and length is based on the dynamic stress orientation. Currently, that works with like I said, with the virtual connections, and we're developing more tools to expand this into the LGR-based methods. Another question is, what's the biggest model that tNav has run? It's kind of hard to say. We don't have access to all our client models, right? But we have seen some models that have made their way back to us. One, for example, had 32 wells with over 1,200 fracs and 10 million active cells. And that was from the Permian Basin. And we have another one from Montney Basin in Canada, which had 33 horizontal wells and more than 700 fracs. So I think those are those kind of covered a lot of the other questions that came in.
Yes, there's another question here, Eddie. I'm gonna read this one. Thank you, Eddie. What was the method used in the demo among the 5 methods? So in this one, we were using the fracture tables. But most of the methods, we have tutorials for them. And if you have more questions, please contact your support engineer locally. And I think we're about to end our presentation today because of time, but there's more questions coming in, I know, and we will be able to answer those individually. Thank you.
Great, thank you all again. We will leave those questions open for a couple more minutes in case you guys have any more questions. We'll get back to you on an individual basis with those, as well as post the questions and answers online in the coming days. Thank you all again. Stay safe, stay healthy, and we hope to see you at our next webinar next week on Tuesday, April 14th, hosted by our Moscow office. Take care, everyone.